Hi, welcome to my video on writing algebraic expressions for consecutive integers. Consecutive integers. Some examples. A, consecutive 1, 2, 3, 4, and if I want to keep on going, I could go to 5, etc. They follow each other, adding on 1. Or you could have 7, 8, 9, 10, 11, 12, etc. Let's look at 2 is 1 plus 1. 3 is 1 plus 2. 4 is 1 plus 3. 5 is 1 plus 4. Notice as you start the first one, 1, you add on 1, you add on 2, you add on 3, you get 4, you add on 4, you get 5. And the same pattern, if you have a 7, if you add on 7 plus 1 gives you 8, and 7 plus 2 gives you 9, 7 plus 3 gives you 10, 7 plus 4 gives you 11, and 7 plus 5 gives you 12. So again, notice you're adding on 1, 2, 3, 4, and second one is add on 1, add on 2, add on 3, add on 4, add on 5. So if you follow this pattern for consecutive integers, if integers are consecutive, then if you let n be the first integer, then the next one, if that's the first one, the next one is you add 1. And if you do the second one, it's 1 plus 2, so it's n plus 2. And the fourth one is n plus 3. So notice the pattern. You add on 1, you add on 2, you add on 3. Add on 1, add on 2, add on 3. That's the pattern for consecutive integers. If 3 integers are consecutive, and n is the first integer, write an algebraic expression for each of these below. A, the second integer. Well, the second integer is you add 1. The third integer is you add 2. 5 more than the first integer. Well, the first integer is n, so 5 more than that is n plus 5. Twice the third integer. The third integer is n plus 2, so it's twice the third. Again, the consecutive integers are n plus 1, n plus 2, n plus 3. So that's the first one, that's the second one, that's the third one, that's the fourth one. Notice the number is always 1 less than the term. Second one is 1 less. Third one is 2, 1 less. Fourth one is 3, 1 less. E, the sum of all 3 simplified. So if you take all 3, the first one is n, you add on n plus 1, and you add on n plus 2. So if you put brackets around these, which you can, like that's the first one, that's the second one, and that's the third one. So first, add the second, add the third. So that's the same as grouping. I'm now grouping the like term together. So n plus n plus n, and 1 plus 2. Notice I'm moving them around. I don't change the signs. So that gives me 1 plus 1 plus 1. There's a 1 in front of each of these. So that gives me 3n plus 3 when you get the sum of all 3 integers. F, the second integer less 6. So the second integer is, the first one is n, the second one is n plus 1, less 6. So that's an n minus 5. G, the product of 5 and the first integer plus the third integer. We want to simplify it. Product of 5 and the first integer is n. So the product is 5n. Plus is an add. The third integer, again the integers are n plus 1, n plus 2. So n plus 2 is the third integer. And you add up your like terms. That's 5 and that's a 1. So that's 6n plus 2. Remember, when you're in algebra, when you simplify, you can add like terms. H, triple the second, subtract the third. Again, the integers are n plus 1, n plus 2. You add on 1, add on 2. Triple the second. The second triple is 3 times. The second one is n plus 1. Subtract the third. The third one is n plus 2. Now, what is subtract? You got to be careful. I have to put the brackets around this because if I don't, I will get it wrong. I'm subtracting this integer. Now, I have the order of operations. That's a 3 here. If you put a 1 right here, which you can, now you can multiply by distributive property. 3n times 3 times n is 3n. 3 times 1 is 3. Negative 1 times n is negative n. Negative 1 times 2 is negative 2. And that gives you 3n minus n plus 3 minus 2. We're grouping like terms, but we don't change the sign because we're not moving across an equal sign. So that's 2n plus 1. Remember, there's a 1 there. It's understood to be 1n. 3 minus 1 is 2. And notice I put a 1 here, but to do that again without putting a 1, let's not put a 1 there just for a second. So if I go 3n plus, that's n plus 1, sorry, plus 3. Now, I put a 1 there to go negative 1 times n and negative 1 times 2. But if you've got a subtraction, you can add on the opposite. So you're going to add on negative n and add on negative 2. So you can do that. So I prefer, think about putting the 1 there and multiplying by negative 1. Or you can do it that way and add on the opposite. Positive is a negative, positive is a negative, and it still works out. Your choice when you're doing your algebra simplification. Now we have consecutive even integers. Consecutive even. Even integers have a multiple of 2. Consecutive, we have a 2, and the 4 is 2 plus 2. The 6 is 2 plus 4. The 8 is 2 plus 6. So notice you have 2 in the difference of each of these. But between 2 and 6, there's a 4. Between 8 and 2, there's a 6. So we're adding on 2, 4, and 6. We have an 8. 10 is 8 plus 2. 12 is 8 plus 4. 14 is 8 plus 6. So notice it's the first one is you add on a 2, a 4, and a 6. A 2, a 4, and a 6. So if integers are even and consecutive, and you let n be the first one, then the second one is n plus 2. The third one is n plus 4. And the fourth one is n plus 6. And again, it makes no difference what you pick. If you pick 24, then you have a 26, then you have a 28. So 24, 26 is 24 plus 2. 28 is 24 plus 4. So notice, 4. And if you put down a 30, then you have a 24 plus 4. 6, my mistake. Make sure everything is okay. Now, if 3 integers are even and n is the first integer, write an algebraic expression for each. So, if they're consecutive even, so is n plus 2, n plus 4, n plus 6, just to keep track. The second one is n plus 2. The third one is n plus 4. 5 subtract the first. 5 subtracted from the first, so reverse it. The first is n. 5 subtracted from the first, so we reverse the order with a subtract from. Twice the second. The second is n plus 2, so twice that. And you could also make it, if you wish, 2n plus 4. So you can have 2 times n plus 2 or 2n plus 4. 2 times n, 2 times 4. The sum of all 3 is if you have 3 of them, you've got an n, you have an n plus 2, and you have an n plus 4. And that's the second one. and do brackets, but it makes no difference because you have a plus sign. The brackets you can put in there if you wish, and you add these up. You get an n plus an n plus an n plus 2 plus 4. So that's 3n plus 6 when you simplify it. 11 more than the third. So the third is n plus 4. 11 more than that is add 11. So that's 11 plus 15. 11 more. Now you take 11 and add on the third one, which is n plus 4. Same thing. And you do descending order. N is first, then 11, and then the 4. But you'll still end up with n plus 15. No matter if you put the third one, add on 11, or 11, add on the third one. You still have to simplify it. G, the third, triple the third, subtract the second. So the third is, let's see, first, second, third. The third is n plus 4. And we're going to triple the third and subtract the second. And this, again, you got to subtract the sign. So the second one is n plus 2. With a subtraction sign, be careful. You have to put that in brackets. If you don't, you will get it wrong. Again, if you did this way, like this, and you did a subtraction, and then you did that, this is wrong. It has to be in brackets to be right. So that's a 1. So 3 times n. 3 times 4 is 12. Negative 1 times n. Negative 1 times 2. Now group like terms. Notice I have no equal sign. I'm not changing the signs. Just group them together. 3 subtract 1, that's a 1 understood. So that's a 2n plus 10. Up here, this last one, I just noticed that's a 24 plus a 6. I believe I went out a little bit too far there. Okay. Now we have consecutive odd integers. Let's look at some examples. Consecutive odd. They run after each other, but they're odd. Notice 1, 3, 5, 7 are odd. 9, 11, 13, 15 are odd. The reason is they do not have a factor of 2. They're consecutive. So 3 is 1 plus 2. 5 is 1 plus 4. 7 is 1 plus 6. 9, add on 9 plus 2, and 9 plus 4, 9 plus 6. Again, there's 2 in the difference here, and between here and here, there's a 4 difference, and between here and here, there's a 6 difference. So you go 2, 4, 6. And you can see there's a 2 difference right here, and right here there's a 4 difference, and right here there's a 6 difference. So 2, 4, 6. If integers are odd and consecutive, if you let n be the first one, then the second one is n plus 2, the third one is n plus 4, and the fourth one is n plus 6. So again, if you notice, consecutive odd and consecutive even have the same pattern because you're adding 2 and 4 and 6. But the difference is you say let n be the first odd, let n be the first even. So what you let n be, then the pattern is add 2 and add 4 and add 6, no matter if they're odd or even. Let's continue. If 3 integers are odd consecutive and n is the first one, write algebraic expressions for each. N is the first one. So the second one is n plus 2. N is the first, notice, n is the first consecutive odd. The third one is n plus 4. 10 less than the first. So the first is n. 10 less than changes the order. Triple the second. 3 times the second. The second is n plus 2. So that's 3n plus 6 if you wish to multiply by 3. 3 times n, 3 times 2. And again, the sum of the 3. So n is the first one. N plus 2 is the second one. N plus 4 is the third one. Notice n is the first consecutive odd number. So the next one you got to add 2, the next one you got to add 4. The sum of all those is n. Add on n plus 2, add on n plus 4. Again, you can put the brackets there. That's the first one, that's the second one, that's the third one, and we're adding them up. And that the plus sign on the brackets makes no difference. So it's an n, plus an n, plus an n, plus 2, plus 4. So n, 2 and 4. And that gives you 3n when you add them, plus 6. F. Twice the third subtract the first. Twice the third. So let's look up the third. Let's see what we have. First one, second one, third one. So twice the third is twice n plus 4. Subtract the first, and the first one is n. So because I have an n by itself, the brackets is not necessary. So that's 2n plus 8, subtract n. So that gives us 2n minus n plus 8. I have to write it in descending order, and the n and then the constant. So that gives us n plus 8. So this bracket is not necessary. So if I wrote down 2 times n plus 4 minus n, then the bracket is this bracket is not necessary when you have a single. G's. 6 times the second plus quadruple the third. 6 times the second. The second one is a c. Let's write them down again. N plus 2, n plus 4. Remember, if you forget, take 8, or they're odd. Okay, take a 9. 9 is odd. 9, 11, and 13. So think about that as n. That's n plus 2. That's n plus 4. That's what I do. I start with an odd number and I go to the next one, go to the next one, and say, what's the pattern? So you see I'm adding on 2, and then I'm adding on 4. So 6 times the second one, which is n plus 2. Add on. Quadruple the third. Quadruple is 4 times the third. So first, second, third, n plus 4. And multiply by distributive property. 6 times n. 6 times 2. 4 times n. 4 times 4, 16. Group your like terms. Put your n's together. Put your numbers together. And that gives us 6 plus 4 is 10n. Add on 28. Simplify. Note the pattern for consecutive even is what in relation to the pattern for consecutive odd. The pattern for consecutive even is the same as the pattern for consecutive odd. So consecutive odd or even is n plus 1, n plus 2, n plus 4. Consecutive, odd, or even, that's the pattern. The only difference is n is the first odd one, then that's the next one, that's the third one. If n is even, then that's the next one, that's the next one. So odd or even, that's the pattern. Consecutive odd pattern is not n plus 1, and n plus 3. Just because it's the word odd, don't mean to say you got to have an odd number. Note, it's not n plus 1, n plus 3. That is definitely not true for odd numbers. People think an odd number, they go 1 and 3. Definitely not wrong. What's the pattern? Odd or even, the pattern is n plus 2, n plus 4. Make sure. There's the mistake. Not that for consecutive odd. If you like my video, click the like button and click the subscribe button if you're not a subscriber. Click the notification bell. More videos coming your way. Write a comment on my video if you wish. Visit my math website, www.mathfullyexplained.com, and there you'll have information on me, my degrees and teaching experience. The video section talks about the strategy you're going to use to help you learn your math. The content section has the topics and the number of videos on each topic. Black font is what's online right now, and the red font is what will be online in the near future. Thank you very much for viewing my video. Bye-bye.